Voice is breaking. Okay. Okay. Is there any exams near?
No upcoming. There's no upcoming.
Okay. So let me explain that today we shall be going to start the very first chapter. That is chemical equations and reactions. Chemical equation and reaction. And reaction. This chapter is important. Why it is important? Because it is the basic for the other chapters like acid, bases, and salts, okay, metals and non-metals, another chapter. Because chemistry has a series. When we start studying chemistry, it must be started from the not started from the middle, okay. So if I'm talking about the chemical equations and reactions here, so what do you mean by the word chemical equation? What do you mean by what chemical equation? So first of all, let me explain what is chemical equation. When we write a chemical change in terms of symbols and formula, okay, any
Okay.
chemical any chemical change in terms of symbols and formula, like for example, you see hydrogen gas burn in air, burn in air. Air means oxygen in the presence of oxygen to give water. Okay, water. So this is a chemical change. Okay, this is a chemical change. And if you write it in terms of symbols and formula, like this formula for the hydrogen gas, this is the formula for the oxygen gas, this is the formula for the water. So this writing of chemical equation in terms of symbols and formula is called chemical equation. Okay, got it? Got it?
Yeah.
So note it down. Writing a chemical change in terms of symbols and formula. Right? If you write it in the word like hydrogen gas plus oxygen gas and it gives you water, it is word equation.
Yeah.
And here you check it that this is H2, this is O2. But you check there are two oxygen atoms, there is only one oxygen atom. Right? So we cannot simply say that this is not balanced chemical. It's not a balanced chemical. Okay. So we'll say that it is a skeleton chemical equation. We use word skeleton or unbalanced. Okay, we use the word skeleton or unbalanced. Got it? So this is, and if we balance this one, it will be considered as chemical equation, balanced chemical. Got it? Similarly, for nitrogen gas when react with hydrogen gas, it will give ammonia. So we write nitrogen N2, we write hydrogen H2, and the formula for ammonia is NH3. NH3, ammonia. Okay, so we'll simply say that if N2 react with H2, N2 react with H2 to gives ammonia. Again, you will check that it is the formula for ammonia. Chemical compound has a fixed formula. We cannot write N2H2 for the ammonia. No, we cannot write it. Okay, so it is NH3. You will check that there are two nitrogen atom. There is one nitrogen atom. There is two hydrogen atom. There is only one hydrogen. Sorry, there are three hydrogen atom. One atom has been created of hydrogen and one atom of air is destroyed, which is not possible. So this is an unbalanced chemical equation. This is an unbalanced. We say that this is balanced chemical equation. You understood?
Yeah.
Understood? But if I balance this one, like if I'm writing N2 plus H2 will gives you NH3. We will learn today that how to balance a chemical equation. So this is N2. We write 2 here. So there is 2 nitrogen atoms. and there's only one nitrogen, so we will multiply by 2. And this 2 nitrogen. Now this 2 is not only multiplying with this nitrogen, this is multiplying with this nitrogen also. 3 into 2, you will get 6 hydrogen. By what number you should multiply here to get 6?
3.
6. So now it is balanced. So note it down. Note it down. So it's the skeleton. Are you writing?
Oh, sorry, I didn't hear you ask. My bad. Sorry.
This is breaking. Not even listening anything now. Done?
Yeah,
Now I ask you that what is a chemical change? We are saying that what is writing a chemical change. So what do you mean by the word chemical change? What is chemical change? What is a chemical change?
that was the thing.
A change in which a new substance is formed. Okay. The change, the change in which a new substance is formed, having entirely different chemical properties, different chemical properties. You done?
Yeah, I'm done.
Okay. So if I ask you one thing here that, like you see hydrogen gas, when react with oxygen gas, it will gives you water. Water. Okay. Now you see here that this is a fuel. This help in combustion, help in burning. Water is non flammable. It extinguish fire. Okay. What you see here is that this hydrogen is a fuel. Oxygen helping combustion, and water is the mixtures which carries both hydrogen and oxygen, so it should instantly catch fire. Should not. But here you see that water has its own properties. Water is not resembling the properties of oxygen and hydrogen. Water is not resembling the properties of oxygen and hydrogen. It is not showing the properties of its constituent. The change in which a new substance is formed having entirely different chemical properties from its constituents. Means it is not showing the property of its constituent. It is considered to be as chemical change. Okay, understood?
Yeah.
Now, if you make a cup of tea, okay, and you forgot, you feel when you take a sip of that one, you feel that it is not sweet. Which ingredient you have missed? That you make a cup of tea. Let you make a cup of tea for you. Okay, and in that cup of tea, you forgot to. This is not sweet. Okay, you forgot to add which ingredient. It is not sweet in taste. Make a cup of tea, you add other ingredients, but when you take a sip of that one, you feel that it is not sweet. It is not giving any sweetness. So which ingredient you have forgotten to add in it? Sugar? Sugar? My voice is clearly audible to you?
Yeah, I can hear you. My bad.
Okay, so which ingredient you have forgotten? That it means sugar. You have forgotten to add sugar. So it means sugar after adding into the coffee, it is still showing its property of sweetness. It is not showing its different property. That's why it is a physical change. Like you are making a lemonade, you add some salt to it. What I'm saying that, for example, you are making a lemonade. You take some water, you feel the taste of water. Okay. When you add salt to it, it will become salty. Then you add sugar to it, it will become sweet. When you add lemon to it, it will be showing all the taste of lemon, sugar, and water. Also, you can't say that it is in the milk. You feel that it is in the water, not in the petrol. Okay, so all the constants are showing their property after the change. So it is considered to be as physical change. Okay, understood?
Yeah, I
Got it?
understand. Yeah.
So what is a physical change? Physical change.
A chemical change is a change. Uh,
I will.
uh,
I,
new substance is formed with entirely different. A new substance is formed with an entirely different
uh,
property.
I can't even understood a single word what you are saying. So
A chemical, I'll try to repeat it again. A chemical change is a change where a new substance with entirely different properties is formed.
yeah, it is a chemical change, but I'm asking for the physical change.
Physical change is when it shows properties. It shows prop. A physical change is when it shows properties of its
Yeah,
previous.
very good. The change in which no new substances is formed, and the constituent still shows a property. It still shows the property after the change. Not it down. Yeah.
Still writing. Done.
Answer me this question. Question, please.
The fourth one.
Very good.
Is it the fourth one?
Very good. Okay. Next question. Which of the following is a physical change? Physical change. These options. Okay. Which of the following is a chemical change?
Um, is it
Which of the following is chemical change?
which of the following?
Is chemical change. Which one?
Is it one? No, wait. Yeah, is it one and four?
Uh, 1 and 4. Evaporation of water, no, and sublimation of camphor. They are not considered. They are physical change. Chemical change is first one and second one.
Oh, sorry.
Okay, why? Because when we quicklime is actually calcium oxide. When you add calcium oxide, when react with water, it will give you calcium hydroxide. There is a chemical change. With a dilution of acids, you will learn that acid when added to water, it will dissociate into the ions. And acid only show their property after the change. Okay, before they don't show their property. There is a difference in the property before and after when they are added to water. Okay. But however, if I'm talking about the camphor, sublimation of camphor, okay. So camphor is means sublimation means when a substance changes from solid to gas directly without going into the liquid state. For example, dry ice directly goes from solid to ice. Sorry, solid to gas without going into the liquid state. So that is still solid carbon dioxide, and after this is also solid carbon dioxide in the gas system. It's not changing. So on simple evaporation, if your water is in the liquid state changing into gaseous state, distilled water is not coming some other substance. Okay. Got it?
Yeah,
Understood?
and
That's why these two are physical change. These two are physical change. But there is no new solution.
Is it D? Is it D?
Hmm? Which one is a chemical reaction involve chemical reaction means chemical change. Which of the following is chemical change?
Is it D the chemical?
Hmm? Speak a little bit. First, second, third, fourth.
Four.
Yeah, fourth. Fourth is the correct answer. Very good. Alright. When you heat copper wire in the presence of air, it will give you copper oxide, which is black in color, and press down. Chemical change. Next,
The first one is the first one physical?
what is the physical change? First one.
Yeah. One is physical.
The first one is physical.
Oh, first one.
Second one, burning of anything is chemical. Okay.
Chemical.
Next,
That one is uh, physical.
let's see this one.
That
We are
that
the
one
same. Carding of an
is chemical. Chemical.
sublimation of ammonium chloride.
Physical. That one physical.
It's not fast. Okay, now we should be moving at why there is a need to write a balanced chemical. Okay. Why when we are writing a chemical equations. So why there is a need to write a balanced chemical equation? So there are two possibilities that, for example, let me explain you. According to the law of conservation of mass, if I took hydrogen, H2, okay, when react with O2, and the formula of water is H2O. We'll explain this that why it is not H2O. It is only H2O, but it is a chemical compound, and here the elements are in fixed ratio like this. So if it is one hydrogen atom has mass 1, so two hydrogen atom will have mass 2. One oxygen atom has mass 16, so two oxygen atom will have mass 30. So here the two total mass is 2 gram when react with 32 grams of oxygen. It should give 32 plus 32, but here it is giving one water molecule. And one water molecule, if you take it, this is 2. Okay, so this will be 2 for the two hydrogen atoms and 16 for this one. Total mass is 18. We will say that the mass of reactant is not equal to mass of product. Mass of product. But according to the law of conservation of mass can neither be created nor destroyed during chemical reaction. We can destroy the mass we can convert it into the energy, but it is not in the chemical reaction, it is in the nuclear reactions. Okay, got it? Total mass before and after the reaction should be equal. Total mass before and after the reaction should be equal. Right? Do you still say something? Your voice is not.
Yeah, it should be equal.
Yeah. The second law is that second law according to Dalton-Nevick theory that the total number of atoms of each type means like something N2 plus H2. will gives you NH3. You count it, it is 4 total here, 2 plus 2. Here it is 1 plus 3. So there is 4 atoms. But he said that the total atoms of each type of the reactant in product must be equal. Atoms can neither be created nor destroyed during a chemical reaction. What does that person say? That atoms can neither be created, can neither be created nor destroyed during a chemical reaction. During a chemical reaction, we can destroy the atom into its subatomic particles, but in the nuclear reaction, not in the chemical reaction. So we are talking about the chemical reaction. So what does it means that the total number of atoms before and after the reaction should be. Okay? What does I teach you? Explain it. Why should an chemical reaction should be balanced? Why should a chemical reaction be balanced? Tell me.
Balance, it should be balanced. The laws, they can't balance.
Because of the law of conservation of mass. And second, Dalton theory postulates that atoms can't be destroyed in a chemical reaction. Okay, got it? Then
Yeah,
clearly audible? Okay,
got it.
so note it down. Why there is a need to write a balanced chemical equation? During the chemical. And the total number of atoms of the reactant and the product of the reactant must be equal to total number. Done? Noted?
Yeah, noted.
So according to Dalton theory postulate, atoms can neither be created nor destroyed during a chemical change. And the total number of atoms of each type must be equal on in both reactant and product side. Have we noted the first and second point completely?
Yeah,
Let's move further. Okay, so question is that why there is a need to write a balanced chemical equation. Now, what are the things that we need to keep in mind while balancing a chemical equation? Okay. So we are just going to write that how to write a balanced chemical equation. Okay. how to write a balanced chemical equation. So there are two things that we need to write, that how to write a balanced chemical equation. How to write a balanced chemical equation. There are the 2 points only. First point is balance that element first. Balance that element first, which is least important. Which is least important. Okay, balance that element first, which is least important. Least repeating means, what do you mean by the word least repeating? For example, if I'm having FeSO4, will gives you Fe2O3 plus sulfur dioxide plus sulfur trioxide. Okay, you will find that oxygen is repeating the least. No, maximum time 1, 2, 3. So we are not going to balance oxygen first. Sulfur is repeating 2 times. We are not going to balance the sulfur first. We'll balance the iron first because it is least repeating. Got it?
Yeah.
Second, in like for example in PbNO3, whole twice. When you heat it, you'll get PbO plus NO2 plus proton. We'll balance that element first, which is least repeating. So which element is the least repeating here?
The
Nitrogen and lead. Nitrogen, oxygen is repeating multiple times, nitrogen is repeating 1 time, and lead is repeating 1 time. Okay. So we'll say that nitrogen, either we can balance the nitrogen or either we can balance the hydrogen. So, okay. Got it?
yeah.
If I'm taking H3PO4, H3PO3, when you heat it, it will give you H3PO4 plus PH3. Which element you are going to balance first?
Balance. Oh. Oxygen. Oh. Oh.
Oxygen is B is repeating. B is repeating 2 times, H is repeating 2 times. Second point is that balance that element at last. Balance that element at last, which exist in its pure elementary or molecular form, which exist in its pure elementary or molecular form. Okay. So for example, if an element is written like O2, N2, Br2, I2, H2, Mg, Na. Okay, so if it is written alone, like example, like CH4, when heated will gives you oxygen plus water plus carbon dioxide. When react with oxygen, it gives you water plus carbon dioxide. So you see that oxygen is in its elementary form, your form it is written. So we will balance it at last. We balance it at last, okay, because it is present. First of all, it is multiple time repeating, moreover, it's found in its element. So we'll balance it at last, okay? We'll balance at last. Balance at last. Have you written the previous point?
I haven't. I haven't.
I have not written. So noted down. Note the previous point.
I noticed it.
Done?
Yeah.
Next. That's the next point.
Finish.
Done?
Yeah.
So what we are doing here is that this one is okay. So try to balance this element like S3PO4 when heated, sorry, S3PO3, S3PO3 when heated to S3PO4 plus PS3. Try to balance this relation. Which element you are going to balance first?
Uh, Oxygen. Oxygen.
So how many oxygen atoms are there? Four. Four oxygen atoms here. And how many oxygen atoms are there? So this is oxygen atom is 4 and here oxygen atom is 3. By what number should you multiply these two numbers so that they will become equal? They can be different numbers. Hello. Have you are good? By what number you should multiply so that it will become equal? And here, there can be different numbers.
They can be different numbers. I know.
25 is by 4, this by 3.
That'll be 12. Both.
Okay. So you have to multiply by, okay, this. So multiply this number by 4, this number by 3. Okay.
Okay.
Now this oxygen is balanced. But this 3 is not going to multiply with this number, okay? This is going to multiply with this 3, this is going to multiply with this hydrogen, this is also going to multiply with this phosphorus. This 3 is going to multiply with this one, with this one, and with this. Oxygen is balanced.
Yeah, oxygen is balanced.
How many phosphorus are there?
How many phosphorus? Four. Four.
So you will learn for 4 phosphorus here and 4 phosphorus here. 3 here, 1 here. Okay. Four. Got it?
Yeah. Got it.
And hydrogen. Check the number of hydrogen. Check the number of hydrogens.
How many hydrogens? There's 7, and then 6.
There is 4 3s are 12, and here it is 3 3s are 9, and 3 here. It's PS3. Okay. So 3 3s are 9 and 3 12. So it is balanced, no? Balanced.
That's balance.
Let's try to balance the next equation. Done. Which element you are going to balance first?
Iron. Iron.
Iron. How many iron are there?
1 and then 2. 1 and then 2.
So by what number you should multiply iron?
2.
Multiply by 2. Now this 2 is going to multiply with this one, and with this one. Check whether it is balanced or not. Check whether it is balanced.
The iron is balanced.
Sulfur, check sulfur is balanced or not. Oxygen is balanced.
Sulfur is not balanced. Sulfur is not.
Sulfur is balanced. There is 2 sulfur here. This 2 is going to multiply with this one, and this is 2 sulfur here, 1 and 1 sulfur here.
Oh, sorry.
How many oxygens are there? Calculate oxygens.
Oxygen is not balanced. Oxygen
Oxygen is balanced or not balanced?
unbalanced. Not balanced. Oxygen is not balanced.
Check how many oxygens are there on the reactant side. This is the reactant side. This is the reactant side. And this one is product side. Check, count the total number of oxygen here. And count the total number of oxygen.
There's 4 oxygen on there. Yeah.
It is not 4, it is 8.
Oh, sorry, I forgot about it. It also multiplies.
It is balanced now.
Yeah, now it's balanced. Now it's balanced.
So, here in this reaction, if I'm talking, here you see that this is disintegrating. This one is disintegrating. Okay. You see that sulfate ion is disintegrating. But if I take reaction like barium chloride when react with, let's have an example like FeOH, Fe2O3, Fe2SO4 whole thrice when react with NaOH, it will give you FeOH whole thrice plus Na2SO4 sodium sulfate. Okay, this is the reaction. If you see here one thing that this Fe and a sulfate ion, okay, FeSO4, we're talking about FeSO4. Okay, so in this FeSO4, you will see that uh, the sulfate ion is not disintegrating. It is same. This hydroxide ion is same. This is a polyatomic ion. It is not disintegrating. Only they are exchanging. Iron is coming with hydroxide ion, and Na is coming with sulfate ion. So unlike here, you see that this is SO4, but there is no SO4 here. So this is disintegrating. Here the sulfate ion is disintegrating, but there the sulfate ion is not disintegrating. It is in the same state. So when it is SO4, we will count it like a single molecule. SO4. So we'll say that how many SO4 are there? 3 SO4. And how many are there? How many SO4 are there? 1 SO4.
One SO4.
Okay. So you have to multiply this number by 3. So that this sulfate ion will also become 3 whole sulfate ion. Got it? Because sodium sulfate means 2 Na and 1 sulfate ion. Okay, so if we have three such molecules, so it will give you Na, sulfate ion, Na, 1 sulfate ion. So in three total Na2SO4, we'll have 3 sulfate ion and 6 sodium ions. Okay, got it? Getting a point?
Yeah, I understand now.
Okay, so this will be sulfate ion, 3 sulfate ion. So here 3 sulfate ion, this 3 sulfate ion. Total 6 sodium ion. And how many sodium ion are there? Only 1. So I have to multiply it by 6. Got it?
Yeah, I got it.
Now this one. Where Fe, now how many Fe are there? 2 Fe. And how many Fe are there? 1 Fe. You have to multiply it by 2. This hydroxide will become 6 because it is 1 Fe has 3 3. It is FeO3. FeO3. OH whole thrice. So it means it is having 3 OH ion. So if you have such two molecules, so in that one you have 6 OH ion. Okay, and here you have 6 OH ion. Na by 6, OH is also multiplying with 6. 3 to the 6 OH and 2 Fe. Got it? So this reaction is balanced.
Yeah,
Understood? Understood?
yeah,
Yes or no?
yes.
Try to balance this one more time. Have you noted this? Noted. Done?
Yeah, noted it.
Right. Oh. Now, let you try to balance this one. BaCl2 when react with NaCl, it gives you, sorry, BaCl2 when react with NaCl, it gives you BaS, BA, equals BaS is what? Yes, in try to balance this one. Done? You balance?
Yeah, yeah, yeah.
So where is there any number here?
No, no numbers there.
Here,
No, no numbers there.
here,
No, no, no,
here.
no. Yeah, there's a number there.
What is that number?
Two. I put two.
It is balanced. Okay. Now C, now try to balance this reaction. CH4 when react with oxygen will gives you CO2 plus water. Try to balance this.
I'm done. I got it.
What's the answer? Say number here.
No, no numbers there.
Here.
Yeah, there's two,
How much?
two,
2. Okay. Here.
and no numbers there.
Here.
Two, there's two, two.
Just 2. 2 oxygen, 4 hydrogens. Okay. Okay. Good. It is balanced. So we'll learn some more tricks for balancing the chemical equation in the next class, okay? Because this is easy that we have done, but the tricky tricks in some question there is tricks, and we're going to discuss in the next class, okay?
Okay.
And after the class, you will be given an assessment. You have to do that assessment. Okay, your link will be provided, and you submit that assessment, and the work will be given to you. Okay, do that. Okay. So, Junaid, I hope you enjoy the class. You learned today what is chemical and physical change, and some basics that why there is a need to write a balanced chemical equation, and moreover, you learned of balancing of some simple equations. Okay, in the next class, we're going to discuss the difficult.
Okay.
Understood?
Yeah, I understand.
Okay, okay, stop. Thank you.